Welcome to part 2 of this Secant piled wall tutorial. This is going to be a slightly longer session because in this session we're going to create a project to host the piles, and we're going to build a Dynamo script which will automate the placement. So let's get going. So we'll start by selecting a new project. In the template we'll use a structural template and then we'll select OK. So of course the project starts at level 2 and this will be fine, we'll just use this and we can always rename it later. And what we're going to do here is use model lines to represent the path of the secant piled wall. So on the Architecture tab in the Model panel, we'll select Model Line, and then we can create a path representing the boundary of our site or wherever we want our piled wall to be created. This can be either open or closed. So in this case I'm going to have something similar to this, and I've got different types of angles, different lengths and so on. And in this case this is obviously closed. The next stage for us is to load in the piles that we created in part 1 of this tutorial. To do that we'll select the Insert tab and we'll select Load Family. We can then go ahead and pick our concrete round pile and select Open, and that will of course load that family file into our active project. So we're now ready to start to create the Dynamo script itself. To do this, we'll select the Manage tab, we'll select Dynamo. So once Dynamo starts, we'll maximise the software and create a new Dynamo file. So the library on the left hand side, I've zoomed into this a bit by holding down the control key and just rolling my mouse wheel forwards or backwards. So I'm just going to make it bigger so you can obviously clearly see where I go within the node library. And the first thing we want to do here is go ahead and select the model lines, and we want to filter this by the category. So to do this I'll select the Revit shelf, I'll go to Selection, and looking down through the tool set here, you can see that I can select one model element by category, or in this case multiple elements by the category. So I'll go ahead and select this one, and the category that I want to filter out is lines. So we'll do a little selection on that, and now we can actually make that selection set within the Revit model. So to do this we can select the select button, and then we can make a window selection set of everything we can see on the screen, and of course now this will filter out just those model lines. Notice that I click finish on the options bar as well. So now if I run this, you'll then see that we have the model curves here. While we're talking about this, I do suggest that you actually have this in manual mode as opposed to automatic mode, and then we'll run this at each stage so we can see the model output. Okay, so let's now go and get the element geometry from this. So we'll collapse the selection shelf and we'll go to Elements and then Element, and here we can see that we can get the geometry from those Revit elements. And of course when we wire these together and click Run, this will then get all of those model lines. To have a look at those we can switch to the background 3D preview mode. We can then do a zoom all and we can then see those model lines. Now, if we take a look at the list structure here, we can see that it's nested, and what we want to do first is flatten that. So we'll go to the list shelf, and then we'll go to modify, and what we want to do here is flatten that list. So we'll take in the element geometry into this, and then when we run this, we can see that we've now got a nice flattened list. Now, as we go, we'll keep things tidy, so I'm going to select these 3 nodes, we'll create a group, and then we'll go ahead and change the group style to inputs. And in this case what we want the user to do here is select model lines. Okay, so that's that first part done. Now looking at inputs, the next thing we want to actually get sorted out is the hard pile and soft pile selection from the family types. So to do this we'll go back to the Revit shelf, and here we'll open up the Elements menu, and then we'll go to Family Type, and here you can see that I can get the family type by the family name and the type name. So we'll go ahead and select this, and of course we need a string for the family name and a string for the type name. So to do this we'll make a code block, so you can just double left click and then we can enter a string in here. So the first string is going to be concrete round pile. Okay, so that's the actual family name. Now the type name in this case was 500 diameter hard pile. Now when you type this in, you've got to make sure that it exactly matches your family name in there, and obviously the type name, and then we can wire these in. Now to check that it's going to work, if we click run, you shouldn't get any errors and you should see the output. If I introduce an error inside here, so let's say that I put in the wrong family name in there, you can now see we get an error. So you've got to make sure that you type that in exactly as it is in the family. So this is getting the hard pile, so I'm going to make a selection of those and just control and drag to make a copy. So in here, this is going to be 500 diameter soft pile. Okay, so we can just edit this here. Okay, and again, when I run that, just to check, I can see that I've now been able to get the soft pile as well. So, once again, we'll group those like we did before. We'll put this into inputs, and here we are getting hard and soft piles. Okay, so that part's done as well. Now the next input for us is going to be the overlap ratio of the piles. Okay, so I'm going to make a code block for this, so again I just double click there and I'll put in 0.8 as a starting point, and then we can just rename the code block here, and I'll just call this one pile overlap ratio. Yep, again, so we can just see what we're actually supposed to be entering into this input here. And then again, we'll actually create a group from this, so we'll right mouse and we'll create a group. I'll make that an input again, so that will be inputs here, and this will be pile overlap ratio. Okay, so there are all the inputs configured for us. Looking into the calculations that we need to make, we need to obviously get the pile diameter from one of these families to be able to actually calculate this overlap ratio. So to do this, we'll need to get the parameter value by name. So in the Revit shelf, you can see we're already in elements, and we'll open up element, and what we want to do here is get parameter value by name. So I'm going to do this on the hard pile here, so we'll get that. The parameter name that we want to retrieve is the pile diameter, so again I'm going to use a code block for this. Once again, you've got to make sure that you type this correctly, because again, if you don't type it right, then you won't get a value here. You'll probably just get an empty field in there. So we want to make sure that we've typed that in correctly. Okay, so that's the diameter retrieved. What we can now do is start to look at some calculations. So what we want to now do is be able to actually calculate the spacing in here. So we'll make another code block, and we can put in two variables in here. So I'm going to start to type in pile diameter plus, or sorry, it's multiplied by the spacing factor. Like so. And of course that gives me two inputs here. So the spacing factor is what we've just created down here. So that's that. The pile diameter is obviously what we've got coming out here. And again, if I run this and look at the calculation, I can now see that I've got a value in this case of 400. Yep. So that's going to be the spacing of the piles to allow us to have that, or achieve that overlap ratio of 0.8. Okay. So now we can start to work with the calculation of the points. Now here I'm getting all of the curves, and what I want to do is be able to calculate those curve lengths. So to do that, we can open up the geometry shelf, we can go to curves, we can open up the curve submenu, and if we look down at the query tools, which are the ones with the blue question marks, I can see here we've got length. Okay, so what we'll do here is just take out that output of list flatten into curve length, and of course when we run the graph we can see now we've got all of those lengths coming out here. So we can now use this output here and the curve length to actually calculate the physical spacing that we require. So that's going to be another code block. Okay. And what we want to now do is have another variable input. So this is going to be curve length. Okay, and I want to divide that by the spacing. So the curve lengths are what we've just derived from this node here. The spacing is of course these ones in here. And of course when we run that, we can now see that we've got potentially the number of points we want to use. Now, looking at how you divide up curves, you can't obviously divide up a curve by 61.5. So what we want to do here is round these values up. So that's going to be a math function. So we'll open up math, we'll go to functions, and looking in here, you can see that we've got something called ceiling, and that will round up. So we'll choose ceiling, we'll wire that in here, and of course now, if I run the same graph again, I can see that I've got those rounded values inside here. Now, if we think about what's actually happening here, as we place out these piles along each of these curves, we want either a hard pile or a soft pile at each vertex. So that means, because we're placing them in pairs, hard and soft piles, we need to make sure that we've got rounded values in here, and also we've got even values and not odd values. So 62 would be fine, but 67 wouldn't be fine. So what I need to now do is, if it's an odd value like 67 or 53, I need to actually add an additional number to that to create an even number of piles. Otherwise what we're going to end up with is two male piles together or two female piles together. Okay, so to do this we're going to actually use modulo. So I've just collapsed the functions area in the math panel, and we'll open up the operators here. And looking down through this, you can see that we've got modulo. And what this does is finds the remainder of a calculation. So we'll bring this out. We can put in the rounded values into x. And then what we want to do is divide this by 2 and then work out what the remainder is. So if we run this now, we can see from the output here that, going back to what we were saying before, if I just look at the values here and compare them, we've got 62, which is obviously even value. Then I've got 67, which is odd, so there's a decimal place there. Same with 53, 70 is obviously even, and so on. So you can see what the modulo tool is actually doing for us. So it's working out whether it's divisible by 2. So then what we want to do is to say, if the number is equal to 1, then we're going to take the number and add 1 to it. Otherwise, just return the same number. So to do this, I'm going to make a code block. And the first line is going to be num, this is just a variable that I'm creating here, is equal to 1. Okay, so obviously if I put the output into here and I run it, I'll get trues and falses. Yep, so 0 is obviously not equal to 1, but 1 is. Yep, so we can see we've got trues and falses in there. So what we want to do here is, if the output is true, we want to actually take the number and add 1 to it. So I'm going to create another variable here. I'll just call this div for division, and we'll say add 1. But if it's not the case, then we can just say take the number as it is. Okay, so you can see here the code block. When I actually run this now, we'll get the division plus 1 or just a division. And of course, to feed that div input, I'm going to take the output from my math ceiling into this. And if I run this now, we can see that we've got the values. Now, what we'll need to now do is create an if statement inside here. Okay, so I'm going to just do a search in the node library here. So we'll just type in if in there and do a search. And you can see here we have the control flow. So of course if I click that, that actually shows me where it is. So it's script, control flow, and if. So the test for this particular if statement is, does the number equal 1? If it's true, then we're going to take the div and add 1 to it. And if it's false, we'll just take the number itself. So of course when we actually run that, we'll get a result, which is an output in here. And you can see at the minute that I've got these kind of nested lists here, and that's because the lacing is set to auto. I want to have this run into the shortest list. So you can see I've right clicked here, select shortest, and if I run this again, you can now see the results coming through. What of course you will notice here is we've now got numbers that we can divide by 2. Okay, and that's really what this whole area in here is doing. Now that we've got this, we can start to calculate those points. So what we want to do is now go into the geometry shelf here, open up curves, and if we go to curve in here, what we're looking to do here is take points at equal chord lengths. Okay, so looking down through this, you can see that we have points at equal chord length inside here. So with this, we know how many divisions we want because we've just calculated those with the output of the if statement, and the curves that we're working on here are all the way back here, and this is the output of list flatten. Okay, so if I run this now, we can see that we've got a whole bunch of curves being calculated, or sorry, a whole bunch of points being calculated there. And again, I want this to be running on the shortest list. So we'll lace that again, run it, and we can see those points now in the model. Okay, now what you'll see is the curves have been divided as we've asked, but there's no point at the corners. Now each of those corner points either wants to be a hard pile or a soft pile, so we'll deal with that in a minute. Okay. Now of course with these points I want to take every other one and divide it really, so we're going to take every other point and that will be a soft pile, and then the ones left over will be the hard piles, yeah, because obviously we need to alternate these with soft and hard piles. So to do this, this is a bit of list manipulation. So we'll go to the list shelf inside here. Then we'll go into the modify sub menu. And the first thing I'm going to do here is use take every nth item. So we'll bring this out. And basically in here we want to feed in the points. And then we want to take every second item. Okay, so we'll do that. And now if I run this, this is now getting every second item. Now I can see what's actually happening here is we want to go down and look at the second level here, because these points don't exist at the first level. I want to do this at the second level. So I can just go in here and say use levels. That's now reading at L2. So if I run this again, and let's just deselect those so we can see the output. Okay, I'll just zoom in to the model here so we can see the preview. You can now quite clearly see every other point is blue. Okay, and that's because it's been selected here. If I want to visualize that better, I can right click over this node and I can just switch off the preview geometry inside there. Okay, you can see we get this grey bar at the bottom, and if I run it again, obviously now we can see every other point has been calculated. Now, to do the reciprocal of that, I can drop every nth item. So let's do that. We'll then take the same list of points in, we'll use the same step of 2 inside here, and we'll run again. And again, I want to do that at L2. So we can use levels, and now if I pick this, I can see those points highlighted in blue. If I pick this one, I've got those points over there. Now, what I want to do is be able to calculate out the corner positions. Like I've said, these want to be either hard or soft piles. So back here, I've got these curves, and if I get the start point, for example, from each of those curves, that will be what I want. So we'll open up the geometry shelf, we'll go down to curves, in here we'll go into a curve itself, and this is going to be a query tool, so it will be the blue question marks at the bottom, and I want the start point. Okay, so I'll feed the list of curves in here, and of course if I run that, I can now see I've got those starting points over here, and what we want to do now is actually join that to this list over here. So looking at this, you can see, in fact if I just zoom in, you can see that this is the one that we want to join to. So to do this, again, this is a list manipulation tool. So we'll open up list, we want to go to generate and join. So what I want to do here is add another input, and I want to take the start points and join those in here. And of course if I run that now, there's the output. Okay, there's all of those points that have been created. Okay, so the next step for us is to create the family instance. So to do this, we'll go into our Revit shelf, we'll open up elements, and of course here we want to go to family instance, and we want to do this by points, because obviously that's what we've just generated. So they're the list of points. And what I want to do here is feed in those hard piles, which is this one over here. Now you can see the wires are going to start to get a little bit messy here. So what you can do is, and this is only in 24, you can pin that wire like so, and then I can bend that out the way so it's a bit clearer as to where that comes from. Right, so now I'm going to switch back into our Revit model in here, and we'll open up the level 1 plan. And the level 1 plan, of course, will naturally cut through these piles as we generate them. Let's then run the script. So in Dynamo, we'll select run, and of course now we can see those piles have been generated. Bear in mind that these are the hard piles that I'm generating at the minute, so I've decided I wanted a hard pile at each corner point down through here. But of course, if you wanted a soft pile, again, you could just reverse that list and have the different family feeding in here. Now, what I'll probably want to do here is just configure the material a little bit better here. So we'll go into Edit Type, and here I'm using my Concrete C40 C50 as we configured in the first part of the tutorial. We'll go to the cut pattern, and what we'll do is we'll just make this a darker grey in here. Okay, and if I click OK up in here, we can now see, obviously, we've got all of those piles displayed. Right, so let's go through now and create the family instance for the other list of points. So we'll go back to buy points again. So we've got the same node again. This time we want to take this list, the drop every nth item. That goes into points. The family type that we're feeding in, of course, is now the soft pile. Of course, again, just to tidy up the wires again, we could use the pin tool in here. So let's put that on. Okay, we can then bend that out the way again. Perhaps something like that. And again, if I run the tool, so we'll just press F5 there to quickly run it, what we can now see is that effect actually happening here. Now, the important thing to notice is how Dynamo and Revit have joined these piles together. So obviously the male pile is taking priority at the moment. Yep. So these are the soft piles here. They're obviously produced first on site, and then the hard piles are cut in. And like we've asked it to do, you can see that we've got one of these elements at the corner of each vertex inside here. Now, to have a look at the logic and see all of this working, I'm going to make a selection set of the model lines in here, and to do this obviously I'll need to be on level 2 because that's where the model lines are. I'll filter the list out, so I'll just go and pick lines themselves, and in here I'll just make a little change to this design like so, and then I'll go into Dynamo, press F5 to execute the script again, and we can see quite clearly how all of this is going to update. Now, of course, because I've now got a fairly tight curve in here, what I might want to do is reduce the diameter of this soft pile. So, of course, again, you can go in here and make these changes as required. So I could reduce the diameter of that secondary pile in there. Obviously, now I might want to increase that spacing factor. So we can go all the way back to our script down here. Let's make that maybe 0.7 now. We'll run the tool again. Okay, and of course we'll see all of these bunch up a bit more to achieve that bigger overlap. And there we are. We can now see that output. Just to have a look at this in 3D so we can visualize it a bit better, we'll go into the 3D view. And here we are. Of course, we can put the visual style on and shading mode on, and we can now see the output of our model. And there we are. So there's the script to create the secant piled walls. Now, like I've said, it is a bit of a long video, so we're on 25 minutes, so you will need to pause this video to take stock of where we are with it, but hopefully that's been useful. Yeah, and obviously the beauty with the YouTube videos is you can pause it, rewind it, and really understand what's going on. Okay, look forward to speaking to you soon.